Hello everyone. Today's lesson is going to be for April 6, 2020. The lesson that we're going to focus on today is going to focus mainly on volume. So I'm going to write this down. We have to define the word volume. I know a lot of you guys still remember what it means. Right? Okay, so we have the word volume. Very simple. So volume is just anything that a 3D shape can hold. So the amount of 3D shape can hold inside of it. Example, imagine we had a cup, right? I'm gonna try my best to draw a cup. As you can tell, it's not the best. So we have a cup, and if I was to fill this cup with water all the way through, as in there's nothing left inside of it, it's at full capacity, that would be the total volume that would be allowed inside that cup, okay? The total volume inside the cup, you can't leave anything in. Now, does it mean that our volume always has to be filled in all the way? No, right? Sometimes the volume might not be all the way through inside a cup or a box or whatever it is. But if you want the total the total volume of a 3D model, example, or a cup, imagine our classroom, right? If I was to take our classroom and just stuff it with, let's say, water, just all the way through, right? There'd be nowhere left for any space. There wouldn't be any space available for anything else, right? Maybe not even any air. So that would be the volume of the classroom. You know, we'd get the calculations at the end. So what we are using for our models or for our shapes are rectangular prisms. And I'm sure you guys remember that word, right? A rectangular prism. Try my best to write this correctly. So a rectangular prism is just imagine a 3D rectangle, right? So a 3D rectangle, and we can't move on without knowing our formula for volume, right? So think about it for a second. Who remembers the formula for volume? Volume equals your length times the width times the height. Now remember that? So imagine I'm going to draw a rectangular prism here. No specific length or width. I'm just going to draw one right off the top of my head. Close this up. There we go. Okay. So we have our rectangular prism, and I'm going to label our length, our width, and our height. So this side right here, we're going to call this our length. Sorry, I spelled it. On this side, we have our width, right? I'll just put W, because you guys already know what that is. And you guessed it, going up and down is our height. Don't confuse the height with the width and the length. That was one of the biggest problems that we had during the school year. Some of us would switch the width and the height together and would throw off our numbers sometimes. Okay, so you have to be careful, especially when they're giving us those measurements already. Okay, so let's look at this right here. So it says a rectangular prism is partially filled with cubes as shown here, right? What is the volume? So now I'm looking for volume of the prism in cubic units. So we're looking for it in cubic units. We know we're looking for volume. I need to write the formula for volume. On a volume, we just said it equals length times width times the height, right? And we need to use these cubes that we have here, right here. We need to use these to help us figure out the volume, right? So we know the volume is the capacity inside of this. We can see that this rectangular prism doesn't give us a picture of it completely full, but we can use what we have here to find out the total volume inside of it, right? So let's start with looking at our length, our width, and our height. So do I know my length? Do I know my width? And do I know my height? If I do that, if I can find those, I can never find my answer, right? So what color do we use? We used pink for length, so let's use pink for our length. I'm gonna count the cubes that I have, and that's gonna be the amount of length that we have, right? That'll be our cubic units. So here's 1 cubic unit here, 2, 3, 4, 5. Let me ask you this: is there another cube there on the corner that we cannot see? Yes, right? Because this cube here cannot be floating in the air. It's not a ghost. It's not floating in the air. There's something has to be under it, right? There's a foundation, there's a base under it. So we have 6, one that we cannot see. So we know that our length is 6. We can jump over to our width, and our width will be counted the same way, except it will be the opposite one, right? It'll be this one right here. So we have 1 here, 2, 3, and the 4th one we cannot see. So our width is 4. And the last one, our height. Same thing. We have 1, 2, and the bottom one that we cannot see is 3. So now I have 6, and it should be times 4. Ooh, what just happened there? 1 sec. There we go. So 6 times 4 times 3. And if I solve these, I can definitely get my answer, right? So let's do this. 6 times 4. What is 6 times 4? Good. 24. Bring down my 3. And I can just solve this right here. I'm gonna write it up and down on the side so you guys can see. 24 times 3. 3 times 4 equals 12. Carry my 1, put plus sign. 3 times 2 is 6, plus 7, 72. So we got our answer choices. We have A, B, C don't look right. Our only answer choice is D, right? So that one's pretty easy. And I'm gonna go ahead and go to the last one. Okay, so it says Adriano stores model airplanes in the container in the shape of a rectangular prism. So we know rectangular prism again, right? We know that's a 3D model. I'm sorry, a 3D rectangle. We know the length is 5 feet. The width is 7 feet. And they want to know the volume. What is the volume of the container? I'm sorry, what is if the volume of the container is 70 cubic feet? Okay, what is the height of the container? So that's what we're looking for. This is a little different. Like we're looking for the height this time. So they're giving us a total. The total is here. And I need to use simple math just to find the missing part, right? So let me draw my rectangular prism. I'm trying my best here. Again, draw this. You guys can draw this as well to help you. I recommend it. There we go. So we know our, what do we know? We know our length. Okay, our length is 5 feet. So that means that this part here is 5 feet. What else do we know? We know the width is 7 feet. Okay, that means the width here is 7 feet. And we don't know our height. So what's our height? That was supposed to change color. There you go. We know what this is, okay? But we know the total amount, right? Total is 70. All right. So what I can do right now is I can solve 5 and 7. I can combine these. I can use my formula for volume. What is the formula for volume again? Volume equals length times width times height. There we go. So we know our length. Our length is, write these down again. Our length is 5. Our width is 7 times the missing part. So let me solve 5 times 7. What is 5 times 7? 35. So we have 35, and we need to get 35 times something to equal 70 feet, right? So 35 feet times something equals 70 feet. Very, very simple. We can do this in our head, or I can do the opposite, right? If I have 70 feet, I need to do the opposite of division, which is what? I'm sorry, the opposite of multiplication, which is what? Division, right? I can divide these two. 35 into 70, and I can already tell you off the top of my head, I know 35 goes into 70 2 times. So what's our missing part? 2. Right? So I'm going to erase this part here. Let me put 2. There we go. 35 times 2 equals 70. How can we double check? 35 times 2. 2 times 5 equals 10. 2 times 3 equals 6. Plus 1 equals 70. Boom. 70 feet. 70 cubic feet. Sorry, 70 cubic feet. Can't forget that, right? So we have 70 cubic feet. So our answer right here is 2. Our missing height is 2 feet. Do we see it? Yep, right there. Very simple. I had to work backwards. This one didn't give me a model, so I just drew one myself. But it's the same exact steps. If you know for formula, if you know the volume, the formula for volume, you'll be able to find it. Okay. If you guys have any questions, please send me any messages, direct messages, or text me. Don't be afraid to ask me any messages. Okay. You guys have a good day. Bye.